This is Alireza, and today I'll present towards deep clustering of human activities from variables. In this study, we consider the problem of deep clustering with variable sensors, where the goal is to develop a deep neural network that consumes raw unlabeled segments and generates cluster assignments in the output. To tackle the problem, we propose a two-stage deep clustering framework, which includes pre-training a multitask autoencoder in the first stage and representation refinement with a clustering objective in the second stage. This is a visualization of our multitask recurrent autoencoder. It is composed of a recurrent encoder, which sequentially processes the input and learns a lower dimensional embedding, as well as a decoder network that takes the lower dimensional embedding and accomplishes two different self-supervised tasks: reconstruction as well as future prediction. These tasks together motivate the network to extract discriminative features that are not only essential to reproduce the input, but also to extrapolate its future. The entire network is then trained end-to-end by minimizing the corresponding loss functions with respect to the ground truth. This concludes the first stage of our framework. In the second stage, we add a clustering network that is trained with cluster assignment hardening. We start with an initial estimate of the cluster centers omega. Next, we adopt a student distribution to generate sub-cluster assignments Q. This essentially uses the similarities between sensor segment representations and the cluster centers as a kernel to compute sub-cluster assignments. We then define a target distribution P by squaring the Q values and normalizing them. This allows high confidence assignments to guide the training process. We iteratively minimize the clustering loss, which is the divergence between the output and the target distributions, to purify the cluster assignments. The whole framework composed of the encoder, decoder, and the clustering network is then trained end-to-end with the aggregated loss function. In order to evaluate the proposed method, we experiment on diverse datasets and present comparison with classical clustering algorithms, as well as state-of-the-art deep clustering method originally proposed for static image datasets. The comparison results are provided in this table. We report performance of clustering methods on the raw input data space, the autoencoding space, as well as the end-to-end cluster assignments. It is evident that our method outperforms not only the traditional clustering methods, but also the deep clustering baselines on the 3HAR benchmark datasets. This highlights the effectiveness of our framework and the necessity of incorporating recurring structures in the architecture design to cater for the sequential nature of the sequences. Finally, we observe that the two stages involved in our framework evolve the feature space from the data space towards a clustering-oriented space, creating semantically meaningful groups of activities. In conclusion, in this problem, we tackled an unexplored problem of end-to-end clustering of raw variable sequences with a deep neural network. We demonstrated the effectiveness of our proposed approach across 3 different datasets, and in the future, we will investigate extension of the framework with new clustering objectives and more rigorous experimentation of unsupervised learned features. Thank you very much.